we are now going to spend a little bit of time getting our head around the concept of mole, which is probably one of the most loved by chemists or hated by students that are not chemists, a concept of the whole of chemistry. A mole is just a number. It's a chemical unit of amount. It's just a convenient number that we chemists use because it makes our calculations much simple. A mole of something, tables, people, atoms of hydrogen, molecules of water, a mole of anything is how many of that something, people, eggs, atoms of hydrogen, that contains as many items as there are carbon atoms in 12 grams of carbon 12. So if you imagine you have 12 grams of carbon 12 in a jar, and you counted how many atoms of carbon 12 there are, as many as there are, that's a mole. If you have a mole of something, it would have the same number of items that whatever carbon atoms you've got in 12 grams of carbon 12. And it's similar to, and that number is being measured, and it's called Avogadro's number, and it's this one. 6.022 10 to the 23 items or particles per mole. So 1 mole of substance contains 6.022 10 to the 23 items of that substance, which is a bit similar to when you talk about a dozen of eggs. Everybody knows that how many eggs you have in a dozen, 12. Well, if you had a mole of eggs, if you have a dozen of eggs, you have 12 eggs. If you have a mole of eggs, you would have all these eggs, which is a very, very large number, which means that it's not particularly useful to measure macroscopic items, people, eggs, chairs, tables. It's very useful to measure small things like atoms and molecules. So again, it's just a particular number of items you've got, which happens to be as many as you have carbon atoms in 12 grams of carbon 12. And we call that Avogadro's number. So you probably have done calculations using moles before, but it never hurts to do even more practice. I'm going to ask you to stop the video now and have a go and try all these exercises. How many grams are in 2.3 moles of water? How many moles are in 17 grams of methane, etc. So stop the video now, please. To avoid making this video necessarily long, I've only picked a couple of examples to solve, although I'm giving you the answer to all of them in the next slide. So I will do these 2 exercises. If you have any questions about any of the others, just drop me an email and we can work through them, or maybe one of the sessions. So the first one, how many grams are in 2.3 moles of water? Okay, so I have my equation, moles equals mass in grams divided by molecular mass. I know I've got 2.3 moles of water. I don't know how many grams of water I've got. And I know I need to divide it by the molecular mass of water. And I've calculated in a previous slide, it's 18 because I've got 2 hydrogens and 1 oxygen. So hydrogen is 1 times 2 plus oxygen, which is 16. If I rearrange this, I have 2.3 times 18, and that is roughly 41.4 grams. So that is how many grams of water I've got if I have 2.3 moles. Or if somebody asks me to weigh 2.3 moles of water, I cannot weigh moles, I can only weigh grams. So I know I will have to weigh 41.4 grams. Now, what if somebody asks me, oh, how many molecules do you have in 2 moles of water? To know that, I need to remember or go and look it up, the Avogadro's number. If I have 1 mole of substance, I've got the same as if I have 1 dozen of eggs, I've got 12 eggs. And if I have 1 mole of eggs or 1 mole of water, I have 6.022 10 to the 23 items. If I have 2 moles, that's double that amount. That gives me 12.044 10 to the 23 molecules of water. So these are the answers to the problems of practicing using moles, molecular mass, mass in grams, and also the concept of Avogadro's number. So hopefully you have you got all of them correct, or if you didn't, you understand where you went wrong. If you don't, please do drop me an email, because we can work through these examples. It is something that you need to be comfortable with, because very often when you are going to perform a chemistry experiment in the lab, you will be using a chemical equation, you'll be using concentrations, etc. And you will see that many of those concentrations and calculations require you to be comfortable moving between moles and grams with this. So it's worth spending a bit of time getting your head around this concept.